Hello 108 students, Mr. McHugh back here with you on page 2. We're going to keep working with finding the vertex except for section 9.6. And this example 2 here, I don't recommend you do this. So you're going to like, well, why are we going over this? But I want to prove to you a couple things, that you go from standard to the graphing formula and that the A coefficient, -3, is going to make it all the way to the final answer right down here. Okay. And so let's just go ahead. I don't think this is worth all the time and effort when -b divided by 2a will give you the x-coordinate or the vertical line and the vertical line of symmetry. But let's just go ahead and practice this for a second. So your task is to convert this from standard into graphing formula. You need to use the completing the square. I was calling it the fudge factor. So here's what you got going on here. You got the -3. You pull it out. Between these two, it's -3 times the quantity x squared plus a minus 2x. Okay, because if you use a distributive property, it brings it back to you. Okay, and then there's the -1. Now that you've got that, you take that coefficient for the b and you divide it in half and square it. So you get -2 divided by 2 is -1, 1 squared, and you get a 1. Now here's what the pain in the butt is. Now you've stuck the fudge factor in here. Equivalency of it is 1. However, to counter it, you don't put a +1 like you did in the outside, which you would remember, a -1 to counterbalance it. You see that -3? You've got to multiply that distribute, so it's really a net a -3 inside. Therefore, you have to do a +3. To me, this is a pain in the butt, and you're going to forget to do that. You're going to look at this and go -1, and you're going to be all out of whack here. So, I don't recommend doing it, but I want to use this for some proofs here. So, you've got a perfect square trinomial. You can factor it into binomial squared, and notice the -3. The a is coming down here, so you know the drill here. You take the square root, of the second term, drop the sign, parentheses squared. Now 3 plus 3 minus 1 gives you the 2. Okay, so now key thing I mentioned, the a coefficient made it into the graphing form, and so it's -3. So from up here you would say this is going to graph down because it's a negative. It's supposed to be the whole absolute value. I just say look at it's a whole number, it's not a fraction, so forth. It's going to be a skinny graph, okay, if you're going to describe it from the last section. And the vertex to this problem is opposite of -1, which is a 1, 2. Okay, now just here one more time, here's some proof. If I ask you to find the line of symmetry and or the x-coordinate of the vertex, you're going to say -b divided by 2a. And by the way, I forgot to put the numbers up here. A is equal to what in this problem? Sorry, I'm jumping there. -3. B equals what? 6. C equals -1. I like doing that. I like identifying those coefficients, putting them in a box. It really helps you focus. Okay, I come over here real quick. -b is what? A +6. So there you go. 2a is a -3. Okay, what's this all equal to? -6 divided by -6, which equals what? +1. Bingo. There's the proof in the pudding. Now, one last final proof. The way we're using this example 3, when you find a vertex, it's the line of symmetry, -b divided by 2a, comma, the function of it. So in this case, we found, can I squeeze it in here? X equals 1, line of symmetry, the x-coordinate, and if I turn around and said f of 1, what would that equal? Now go back up to the equation, -3 times, we're going to put a 1 in, we're trying to find the output, which will be the y-coordinate, and then we've got what, plus 6 times 1, remember what, we're replacing x with 1, minus 1. Okay, now I do that real quick. I get -3 plus 6 minus 1. Final answer, what, 2? And there's your proof again, the pudding. Okay. So, I was thinking about this. If somebody asked you to convert from standard form into graphing form, couldn't you do this shortcut? Bring down the a coefficient. Instead of putting -h over here, put -b divided by 2a. I'll bring the minus in there, and then for the k, put f of that The book doesn't teach it that way. And I don't know if you really need it or not. And I actually more think about it, I don't think it's a homework assignment, just kind of me learning a little bit more about parabolas, teaching it. So, what's the shortcut method? Without a doubt, use negative b divided by 2a to find the vertical line of symmetry, aka the x-coordinate of your vertex. Once you know the x-coordinate, substitute it into the function like we did, get the output, which is your y, and that's your ordered pair for the vertex. Okay, now example 3. I think the book would have done a better job sticking with the previous example. Would they come up here and they pick x squared minus x minus 6 and they tell you use the fast shortcut formula to find a vertex. The vertex, this v by the way, is just a notation telling you it's the vertex, and it's the ordered pair negative b divided by 2a. Again, that's the line of symmetry, and comma the function of that x coordinate evaluated to get the output y. Okay, now I'm all for fractions. I'm not saying we're supposed to be against them, but the book could have done a better job by picking a problem that did not have to introduce fractions, because as soon as you identify your ABC, find the line of symmetry, negative b divided by 2a, look what you get. Negative times a negative is a positive 1. 2 times 1, that's a half. Holy moly. We like to work with whole numbers. So, we live with it. So we know the vertex right off the bat is the x-coordinate, or the line of symmetry is x equals 1/2. Then you've got to find the output when x is 1/2. Input it in, grind away through the fractions. 1/2 squared is 1/4 minus a half minus 6. Get yourself common denominators over here. A fourth, you get 1 minus 2 minus 24, and you end up with negative 25 fourths. Okay, and that becomes your y coordinate. Okay, then we're going to go ahead and graph for that. So we'll bear with it. It would have been a lot easier if they would have had some standard ordered pairs of whole numbers, but they decided not to go that way. Okay, but I'm following the book. So I'm in example 3 and 4 in the book here, page 542, 43. Okay, class. Hey, I'm going to sign off here now. We've done page 2. Hopefully you get the idea that the line of symmetry is negative b divided by 2a. Take that result and find the output of it in the function to get the x-coordinate. Okay, page 3, we're going to actually go ahead and do some graphing. It looks, well, we're going to find the vertexes again. So I'll see you on page 3. Take care. Bye.